So I'm sure all of you have heard various definitions of artificial intelligence, and here I will borrow a little bit from one of the first persons who actually coined the term artificial intelligence, John McCarthy in 1956. They had a meeting of a lot of AI, a lot of researchers. They met at Dartmouth, and that was the first time he coined the term. And what people usually misidentify AI is actually thinking about borrowing like Hollywood images of walking, talking robots or humanoids. But AI is a very broad field, and there are multiple subdivisions under that, like vision, speech, language processing, and predictive analytics, etc. But the most common usage that we all know as consumers will be the Netflix and Amazon recommendations, tagging your friends and family on Facebook, or even your voice bots like Siri and Google Home, Amazon Echo that you would be using. So consumers are increasingly using AI at their fingertips, sometimes with or without their knowledge. As usual, enterprises follow consumer technology innovation. So enterprises in the last 3 to 5 years have started adopting artificial intelligence applications as well. So let's take a look today at some of the use cases if you are an enterprise, how you can actually, how you can start implementing in your organization. Sorry, I got carried away with trying to admit somebody who was trying to come in. So when you talk about enterprise adoption of artificial intelligence, there are specifically a few use cases you can think about in terms of machine learning, which is like 90% of the most common applications in an enterprise is machine learning. The other 10% could be robotics, which obviously is more and more used in manufacturing at scale, when you think about at scale use cases. And under machine learning, you would have heard terms like supervised learning, unsupervised learning, reinforcement learning, and natural language processing. And what I will do today is map some of these use cases to actual business problems that you could solve, that you can think about in your organization. I don't know why it's, okay. So here I'm going to cover 5 use cases today. The first one is predictive analytics. This is the most common use case that we see very often in organizations. I think sometimes my screen, okay, there you go. Okay. A very, very common use case is fraud detection. You would have heard about it in your financial services, where credit card fraud detection uses machine learning algorithms. So basically, machine learning learns from vast quantities of historical data to predict a future outcome. And in this case, it would learn from vast quantities of your of any fraudulent activities that have taken place in your organization for the last 5 or 10 years, and then build predictive models to detect what are some of the fraudulent patterns. This obviously will save credit card and financial organizations tons of money, because I'm sure when you would have had a use case when you actually, somebody misused your credit card, you might have experienced inconvenience, but the actual person who's experiencing a financial loss is the credit card company. I remember a time when my credit card was misused, and suddenly I had bills running to $4,000 that I did not spend, and my bank thankfully paid me the $4,000. So end of the day, the bank was losing the money because of the fraudulent activity. So the earlier the bank detects the fraud, the better it is for conserving their financial transactions. So in this use case specifically, what you can think about is similar fraud detection. The other use case I'm working on actively is basically Medicare and Medicaid fraud with US federal agency called CMS. CMS actually administers the Medicare and Medicaid that the government gives money. Obviously, healthcare provider fraud is actually very common. It runs into millions of dollars. So We are prototyping some machine learning tools there to predict which healthcare providers most likely are doing fraudulent transactions. Okay, another example I want to show here is machine failure of a ship here. In this case, this is an interesting use case that one of the organizations I know has implemented for the US Navy. So the problem they were trying to solve is US Navy has actually their ships in multiple ports throughout the world. And one of the challenges they face is sometimes when they're in the middle of the ocean, one of the parts get broken down and they have to go to the nearest port in order to replace the part, depending on how much it impacts the ship's voyage. So one thing they did was actually take all the past history of repairs they've done. This included like manual handwritten notes and historical transaction data. And based on that, they were able to predict what is the probability of a machine inside the ship failing. And obviously they had to prioritize the failure because there are multiple components in the ship, but what are the components that impact the voyage could be prioritized. And even if they did not predict to a 100% degree of accuracy, it was still helpful because if they could predict to an 80% degree of accuracy, the ship could still carry some of the spare parts and prevent that whole voyage to the nearest port. So this was one successful use case of implementing predictive analytics in a business scenario. The second most common example is text analysis, and we have seen this successful usage in even 5 to 6 years back. So a common use case, again, since I'm in Washington, DC, I'm going to bring up a federal agency, US Citizen and Immigration Services here, actually implemented Emma nearly 4 years back. And Emma uses natural language processing, and it's able to assist customers who have inquiries about their immigration status or their green card status or their citizenship service questions. And Emma is able to handle not only English inquiries, it was able to handle even Spanish inquiries, and saving US CIS a lot of hours in handling multiple customer inquiries. And one of the questions that often asked is, so does that mean that they got rid of their customer service representatives? Not really. They still have their customer service representatives to handle the most complex inquiries, so that the dull and mundane is removed and this chatbot handles it. And similarly, in my own organization, since COVID struck, we have actually developed something called CODA, which is a COVID-19 digital assistant using natural language processing, which can help a business to reopen safely by using it to screen questions so that we minimize the actual contact. The second most common use case you would have heard is the sentiment analysis. Obviously, social media is used by small and large organizations today, and a lot of large organizations want to understand how they can use their social media strategy more effectively. So if they introduce new products, how can they use it effectively to get feedback? So for example, if Burger King introduces a new juicy burger, they can easily find out how many people on social media are not liking it and how many people really love it using natural language processing. And we also know like real-time sentimental analysis was used in Canada when they had their government conference to get inputs from people on social media so you can analyze what the people are feeling and the sentiments around that. So think about one of the use cases of using your marketing strategy and using your machine learning and natural language processing in that use case. The next one I want to present is segmentation. So obviously for any business or even a government agency, the customer segments is most important. I remember a story 10 years back when cloud was cannibalizing traditional data centers. I used to work for a company that had data centers, and one of their problem was customer retention as people were moving away from data centers and migrating to the cloud. And there, the problem they were trying to solve is how can we retain customers, and what percentage of the customers are leaving me and at what rate, right? So this is where customer segmentation using machine learning will be really helpful. So essentially, you find out based on the past historical transactions of the customers, what are some of the things that they're interested in, what is the dollar number that they buy, and how to increase those transactions. So if you have, in this case, if there is, the red is represented by people who buy a lot from you, you don't focus as much on them, or focus your marketing and sales on them as much as converting the yellow who don't transact with you, but who are at a midpoint. Retail uses this very effectively, like Nordstrom and others, and Netflix and Amazon recommendations increase their product, especially Amazon increase the number of purchase transactions. So this is another use case to think about. The second one is an interesting use case. We live in interesting times. In the last 5 years, fake news has been used to change the narratives and polarize societies. So there are a lot of startups in the AI space who are looking at detecting fake news. And this is one example of segmentation as well. I'm going to pause here, and looks like there are some people waiting in the waiting room. I'm going to admit them. Okay. The next I want to focus on is image analysis. In the past, I have worked on some of the projects that involved looking at CT scans for lung cancer patients. So medical imaging is one of the use cases. So in the example of my project personally, what I can say is it was taking multiple hours for a research scientist to look at the CT scan image and actually identify certain components of, for example, they were trying to identify what is the visceral fat in that CT scan and how it impacts lung cancer. And it was taking them multiple hours to do that. And we wrote a machine learning algorithm, not only to calculate the visceral fat in the CT scan, but also how it correlates to the lung cancer patients as well. So medical imaging is one of the very important and use cases that's been implemented. Image analysis for criminal investigation. Again, this is another use case that's not only used for by law enforcement agencies, but sometimes it's also used for by government agencies, as well as at a very hyper localized area by even houses in an area these days that are helping law enforcement. So when you talk about image analysis, obviously questions about data privacy and privacy of your photographs or your name or PII data comes into play. So what I want to emphasize here is this need not necessarily emphasize on an individual, but more on the large number of people that might be congregated in a specific area. But if you have seen the movie Patriotic Act and about the Boston bombings, you saw how long it took actually the law enforcement agency officials to find out how the profile of the bombers were. And it took them several days actually. And using machine learning, you can actually break it down to a few hours, if not minutes. And I have heard feedback from law enforcement agencies that this technology is still very expensive for them to be rolled out or affordable for every agency. But I think we at least know that it's capable to do it. So I think it's a matter of time as your processing power costs are coming down. The cost for this also will come down. Last use case I want to talk about is a smart city. Smart city is the concept that's based on Internet of Things or sensors that are placed in multiple areas of your city. And smart cities have been implemented to improve economic opportunities for people, to improve your traffic patterns. Basically, during peak times, you want to ease the traffic. Like in this example, I think PennDOT implemented a sensor network in Pittsburgh, and they had 155 sensors. And this is what I called as artificial intelligence on steroids, because here you're not only using artificial intelligence, you're actually getting data from all these sensors, which is basically the convergence of Internet of Things and AI to make decisions. The second is the smart building. So obviously with our whole focus in building sustainable environments and communities, we want to focus on smart buildings, which depend again on Internet of Things and sensors to detect fire safety, lighting, HVAC, energy management. I think those of you who are using Nest in your house are doing that at a smaller scale, but think about a lot more sensors throughout the building to enable a smart building. And I know there are multiple initiatives and incentives provided by government also to implement smart buildings. So in order to get started, obviously you would think about some business use case in your organization. Also, you have to think about what are your data sources, because too often organizations want to get or sprinkle the pixie dust of AI, but they don't know where the data resides or what the data sources are. So it's very important to understand that. And lastly is the ML models, which is the machine learning models, algorithms, or the AI systems. Too often, people who want to start implementing AI start at the third point. They think, oh, let's bring in a data scientist, let's start writing some algorithms, right? So what's important is you want to take a step back, think about what business problem you're trying to solve, and then think about what data can support that business problem, and then you think about the ML models. So here I present the AI playbook that I co-authored for the US federal agencies. That is a framework that can help any organization implement AI. So this has 5 phases. If you look on the left-hand side, it has assessment, readiness, selection, implementation, and integration. And this is on GitHub also, so I can share it in the chat later on for you all to access it. It's open source. It's an amazing framework that focuses on each and every, like you can see, there's each and every activity that we describe in detail. I would say the most important of these phases is assessment. The more time you spend on your assessment phase to assess what is your use case, what is the business problem you're trying to solve, as well as actually your impact to your people, because too often people don't want to talk about the impact to your people and your process. So there is a statistic that says that for every dollar you invest in an AI system, you will spend $100 in change management, how it impacts your people and processes. So it's very important to spend time on your assessment so that you get your return on investment on your AI implementations. And everything else is like readiness is preparing the organization and establishing the stakeholder committees as well as the working groups. Selection is selecting what kind of technology platforms you will use, whether it's open source or COTS platforms. And this phase is also very important, because one of the things when it comes to machine learning and AI is they're talking more and more about transparency and explainability. How transparent can the system be? And I think going the open source route will give you more flexibility in terms of transparency. So definitely spend time on the selection phase as well. Obviously, implementation is where the rubber meets the road. And then integration is how your system can integrate with other business processes at the back end. And these are the key steps of implementing of a use case. You identify your business objective, data sources, perform some data analysis. This is where your business rules comes into play. Then you train your data set, you do the modeling, validation, evaluation, and deployment. I know I'm covering very quickly, but just to present a bird's eye view of what the life cycle of an AI modeling looks like. What are some of the key challenges when it comes to implementing AI systems? I've already spoken about data quality. Those are some challenges, but Carolyn is going to cover a lot more in detail about bias, ethics, and all that sort of good stuff about the key challenges, but keep in mind that the outcomes and the implications of an AI system are very, very important when it comes to the key challenges of an AI system. And at the heart of that is the biased data that we often talk about. And what I like to say is there's nothing like unbiased data. It's always important to think about bias in the data and how you can assess it and what are the trade-offs you have to do while implementing the AI system. So thank you. That's all I have for you today. I would like everybody to connect with me on LinkedIn for further discussions. I post often videos and conversations around some of the projects I'm working on, and I also post them on my YouTube channel. So thank you for attending this event, and I will pass it on to Carolyn, or I can actually stop the share and see what sort of questions, if I can take one or two.
Perfect. Thank you, Swati. Maybe we'll just take one question there, and then we'll hand over to Caroline. And then at the end of this session, we do have time for Q&A, so you can interact with both of the speakers. So
Sure.
we'll take the very first one. Is regarding the ship example you showed, Swati. Can they use Internet of Things to feed the machine learning model?
Yes, absolutely, absolutely. How do you sell it to marketing stakeholders as well? So regarding the ship example, again, it's not, don't start with the question of can you use IoT for the machine learning model? Start with what is the problem you're trying to solve. Are you trying to solve the prediction of a machinery breaking down, or are you trying to solve to detect what is the humidity in a ship, which is important? So yeah, two different problems. And if you're trying to detect humidity and temperature, yes, I will use an IoT sensor in the ship. So that's in a nutshell.